Video I am going to show you, basically demo you how to insert, update and delete data on S3 using Hudi and Amazon EMR. So what in this playlist I have uploaded two more videos, where in the first video I have told about the complete Apache Hudi overview, and then the second video I have told and demonstrated how to run the PySpark notebook and how to configure Hudi in order to work with the Hudi datasets and all. So I highly recommend go and watch those videos if you want to do practical from this recording. Okay, so first thing first, so what we are going to do, we are going to see what are the setups are required in order to play with the PySpark notebook with Hudi. And also I'm going to do like getting a dummy data and try to generate a record on Hudi dataset and try to insert, update and delete some records. And even also I'm going to show you the underlying schema, how these two types of storage works with Hudi datasets. Means we have two types of storages, like COW and MOR, so copy on write and merge on read. So these two tables I'm going to show you from the underlying file perspective, how actually data sits on the Hudi data sets. And we are going to fire a couple of query where we are going to see what is the incremental queries, what are the incremental data. Then we are going to fire query on COW table, we are going to fire query on MOR, where we can see read optimized view, and where also we can see real-time view. So let's get started. Let me run this. These are the couple of configurations you need to run in order to work with the mm, basically you're providing the Hudi jars to your PySpark notebook. That's it. So this is the next thing. I'm going to generate a dummy data frame, where this data frame you can see if you can getting a record, you can create a scenario like where you want to have some database coming in a CSV or S3. So what you have to do, you have to convert those data sitting on CSV S3 in order to create Hudi dataset. You have to first convert in a Spark data frame. Then you can write that Spark data frame to in order to create a Hudi dataset. So it's like the first thing is you have your data, CSV data on S3. Then on top of that, you are going to create Hudi dataset. So I'm just simulating the same behavior here, where what I have done, uh, I have taken some sample data, where you can see I have some ID, I have some creation date, then a status also I have in the data, and last updated time. So let me run this. Okay, let's run. Let's quickly see this data also, how it looks in the data frame perspective. So you can see our data frame is ready with ID, creation date, status and last updated time. So these are the four columns I have taken. Now the next thing is like you have to do couple of Hudi configurations. Basically we are going to write spark.write, where we are going to give this data frame as an input, and also we have to provide some options. So in order to work with Hudi dataset, and in order to create Hudi dataset from your data frame, you need to provide some options, or you can say configurations related to Hudi specific, right? So Hudi comes with, for more, if you want to read more on these Hudi options, and you can go to this official document, where you can see that what are the things are required if you want to write if you want to use Spark Writer API to create Hudi dataset. So these are the options are there, but what are the main configurations I will going to tell you right now. So first thing first, what I am setting up, I am setting up my path, where I have created this I have this bucket created, my Hudi upserts. Okay, and here I have created one more folder, my Hudi dataset. So here what I am going to do, I am going to create Hudi tables here. So this is my parent path, and inside I am going to keep my table. So this is my dummy table name, the Hudi table name, and couple of Hudi options I am going to provide, which I am going to pass these Hudi options to spark.write API. So here I'm setting a table name, and this is the record key field. So as you know already, in the uh, a Hudi table, every record is identified by the primary key. So here you can treat record key as a primary key, and you have to provide that which column you are going to take it as a you can say unique column. So because in Hudi, Hudi play with the indexes, means it can identify the row, every row with the index, and you must have a primary key column. So that's why I am here treating this as a primary key column. So I am passing this as a record key. So in Hudi options, it's called as a record key. You have to, then we can configure, this is optional, but let's say you are creating Hudi tables and you want to uh, create partition on created date. So that's what I'm passing. This means I want my partition to be on this creation date column. Pre-combine field I am setting here as a last updated time, means this is required where once, let's say, uh, because it's like Hudi provide you condition, you can do continuous ingestion data, you can do upsert delete. So let's say same record again came. So in order to take a decision, what Hudi will take this column, the latest value, and uh, insert or update uh, the record, right? So let's say if you have two duplicate rows, so which record it is going to take for the latest, in order to give you a view of a latest record. So it is going to decide based upon this last updated timestamp. So you can give any column, but basically we used to pass like timestamp column, because it will have like updated time whenever you are doing some update or insert you are doing. So this is to mitigate the, uh, in order to stop this, like how you're going to stop this the duplicate records in the Hudi data set. So that's the thing. There's a couple of configuration related to Hive. Okay, so that's not a big deal, you can remove it also, but these things are required. So now I am going to run this. Okay, now what I'm going to do, you already know that I have this input data frame already created. Now I'm going to create Hudi table on top of this data frame. So let's see what I'm passing here. Input df.write. This is a normal Spark write API. Here format you have to pass org.apache.hudi. So this is the Hudi format actually. And like options, we have just options. We have like all the options we have set it up here. We need to pass it here, and we need to provide this. I kept it as a separate option because based upon the operation, what you're going to do, you're going to do insert, update, or upsert or delete. So that's why I keep it isolated, so we can set it up here only, right, based upon our insert, upsert, delete requirement. So you can see, and I'm setting writing mode as a override, so it will override if there any data exists. So what it will do, it will go and save it to the input s3 path plus table name with the table name in a Hudi format actually, and Hudi saves file by default in a Parquet format. So once we are going to see the underlying architecture and how the files created and how the tables are created there, then you will be having more understanding. So let's run this. I'm running this cell. Okay, so it's done, I guess. Now quickly verify the tables. Let's say just any record came here or not. Just check. See, so this was my like bucket. Here I have given like this path where I have created Hudi created this table. So you can see how it's created. We have like what we have done here. We have like provided options where it is like partitioning the data based upon creation date. Okay, this column. So these these all records go to this partition, and these all records go to this partition. You can clearly see here. So it's created. So these are the some meta file it's created. So let's go inside this. Yeah, so Hudi actual records are here actually in this Parquet file, and this is the metadata. So like Hudi, in order to identify, okay, in order to, because by default we have created this table, this is copy on write table. So it is copy on write table, and let's say I am again updating a same record. So what it will do, it will do a new version of this file. It will insert a new version of the files, and everything it stores in the metadata. Okay, so which file is the latest one and which value is the latest one, I need to show to the user. So this everything goes into the metadata, and actual record sits in this Parquet file. Okay. So up to now we are fine. Now let's like update one record. So what I am going to do, I am going to like mm, for ID is 105, I need to fetch this record, and I will apply some of the I will change some column values, and then we'll do a upsert actually what I'm trying to do. So initial thing is our record inserted and Hudi data set created. Now we are like modifying one record, you can say. So see, I took this record 105. So the right now the state is ID 105. The status is unprocessed, and this is the last update time. So now I am going to do, I am going to just change these values. Status I am going to change it from unprocessed to processed, and last update time I am changing from this value to, let's say, some latest timestamp. Okay. So I want to show you now what my this updated data frame looks like. Then I will fire this spark.write with upsert command for Hudi upsert. So you can see my this record changes to unprocessed to process, and timestamp also changed. Okay. Now I will take this data frame. So you can say I need to upsert this modified record. So what the everything is same. If you have like whatever data frame you can take this data frame dot write, the same thing. Options, here we are changing the write operation. Here it was like the first time we are doing insert, so we insert. Now it's like upsert, so it can handle both the thing, even delete also, even insert also. Okay. And the next thing is like we cannot overwrite now because we already create tables are created. Now we have to write the files Hudi tables in appended format, right? So I'm rerunning this. I'm running this actually. Okay, so it's completed. Now quickly see, let's say I am querying the same table. Okay, and let's see whether it is changed or not. So see, it is changed. Initially it was like unprocessed and having timestamp 2015. Now you can see it's become the processed one. The status column changed, so we are able to modify a record. Now let's see what is the underlying file behavior Hudi does with this copy on write table, COW table. So by default it is copy on write table. So maybe we change record 105. So 105 is in this partition. So let's go to this partition. See. So initially it was one Parquet file, and the new version is created because we have started a new record. So everything is stored in the metadata. And see, once you are querying it, Hudi is very smart enough. It is not showing you to the, it will show you from the latest version of the file. So from there, and it is not, and why it is faster, why Hudi is faster in allowing upserts to the data lake, because you can see it's just only updated this file. It's just create a version of this file. It doesn't touch all the other files. But in case of normal HDFS or normal S3, want to delete anything and distributed storage, first you have to like re-download everything, then recreate, then re-upload everything. So it takes a lot of time. But due to this thing, Hudi dataset, it's allow you to do like very fast ingestion, and you can do everything very quickly in the data lake world. Okay. So now let's say I want to do a incremental read. So before that, I want to show you actually Hudi will add some more columns, that it's proprietary column, you can say. Some of the columns it will append into your table, that is for Hudi purpose. So I will show you what are those actually. So this is our actual columns: ID, creation date, status, last update time. Hudi used to add this underscore hood wherever your column you're seeing underscore Hudi, it's like Hudi created columns. So Hudi commit time. So it keeps a commit time of every record, right? So at what time it, so let's say, see, we have changed, we have like the very first time we committed the record with this timestamp, the very first insertion we did with this timestamp. Okay, later we updated this 105 record, so it, and committed also, so it took the timestamp from the next upsert, not the old one. Okay, so these are the some of the things, Hudi, and where is the record key, which is the record key, and where is the partition path, everything it's like try to keep. So now what I am to do, I just want to file an incremental query. So what incremental query, I want to see what are the records just changed. We changed only one record, I want to see that record. So how we can see, like we need to pass this Hudi commit time actually, because every commit time there is a different time frame, different timestamp. We need to give that time frame. Okay, I want to see from after last commit. So our last commit happened in this timestamp. We will provide this timestamp, so it will show us, okay, what record has changed after this, after this time or after this commit. So that's that, in this way you can get the incremental view. So now let's see this. I am running this in order to get the distinct Hudi commit type, so that I will be having what are the distinct commit type. So see, we have two timestamps. So what I will be doing, Hudi will give you like read options also, where we can like use the Spark Read API, and where we can pass the read options. So what read options we are passing here, we are passing like we want to query this uh, data source or Hudi dataset from incremental perspective, right? So we want the incremental view of this particular table on the given time. And there is one more time you have to set it up, like instance type. After what time you basically you need to see the change. So this is my last commit time, so I want to see after this commit time what the changes I have done. So that's it, I need to pass these things, incremental and this timestamp. Okay, I ran this cell. What I did, like I read those things, incremental thing, and put it in this SQL table I just created. Okay, and then we'll query this table to see what the actual data is, what the incremental data is. It is taking some time, let it be. Let's give some more time. Okay, so I think it's completed, because we are not seeing anything, we are not doing any action. So let's try to see this from this table, from this query. So what I am doing, I am selecting this commit time also, ID, creation time, creation date, status, last updated time from Hudi, and like dot so we are doing that. So So see, we got this incremental whatever the changes we have done. So see, we got it like what changes we have done. So you can like time travel also. You can go to the any time and you can find out what record you have changed and you can actually roll back also. So there are a lot of uh, mm, flexibility Hudi provides actually. But this doing to a normal data lake, it was a very cumbersome process. And here you're just firing a SQL like query and you're doing right. Let's delete a record. I want to delete this the 105 record. Okay. So first create a data frame out of this. Right, so I want to delete this record. So what I will do, I will do a write the same thing at df upsert dot write, and we need to provide this write operation as a delete like we did insert upsert. Now we have to pass it as a delete. So Hudi will delete this record from Hudi dataset. So let me run this. Okay, so it's deleted. Let's quickly check that, quickly confirm whether what's the recorder showing or not. So we deleted like 105. See, it's deleted. Fine. Now there is no 105. So this was up to like this was for the copy on write table basically, because it's the default one whenever you're trying to create a Hudi dataset. Common storage type is copy on write, COW. Now let's see merge on read. So what I'm doing today, I am going to like give the same path, and but I am going to give like a table name as a different table name because I want to save it as a different table name. Okay, but before that I want to show one thing in my glue catalog. In my Spark catalog, what are the like tables are there? So see, this is what we have created. Okay, we have created my Hudi table and the incremental table we have created for our query purpose. So but is the this is the actual Hudi table. Okay, we'll so this is called as copy on write table. So next thing is like we have to see how to create this merge on read tables. So only thing you have to pass one more parameter like a storage type. By default, if you're not providing, it will be your copy on merge, right? So but we want it merge on read, so we need to specify this storage type merge on read. This is the only change. And the new path, new table name, I'm going to store in different folder. So that's why I've given this my Hudi table underscore MOR. This is going to hold this MOR table. So let me run this cell. Again, I'm doing the same thing like uh, so before that I want to show you what is my input df command. So right now, one second. Just want to show you what my still input df still looks like, and I want to use this input df in order to create a merge on write table. Okay, so see, this is the having the same records what we have seen previously. So I'm using this same data frame here in order to write table. So let me run this cell. So here what I have shown you till the time it is running, I want to tell you one thing. Here what we have seen in case of copy on write table, in copy on write table, if you are updating anything in the same value which already exists, if you are upserting anything, it will create a new version of the file with the updated record. But in case of MOR, a log will be created along with the base file. Okay, a log will be created, and the new whatever the changes you are going to do, it get appended to the log file. Log file is basically a Avro, and this base file is basically a Parquet. And once you are reading those on merge on read, so it will merge both the files, means the base file and the log files that I am going to show you. I think it inserted. Let's check in the file directory side. Yeah, see my Hudi table MOR created, and it has all the records also. So right now it is fine, it is in Parquet format. So the first time we have inserted, okay, it's created a partition same like that. Okay, now what we are going to do, we are going to like update one record. Same thing we are going to do here, but here I want to show you one thing. It's create a table with the two tables it creates basically. So we just saw like this is the Hudi table, this we have created from the Spark SQL side. So my Hudi table, this is copy on write table. Let me again fire this same show tables query. So now this we have created two more sets. So this is MOR. So MOR come with two views. So that is, this is called MOR underscore RO means read optimized, MOR underscore RT means real time. So merge on read table supports two type of view. One is called read optimized, one is called real time. Read optimized is like it will, even after you have updated a record, okay, so it will give you the like read optimized view means whatever the things committed, right? Because you are, I will show you here what happens actually. Let me fire a record, then it will be self-explanatory. So what we have done up to this. Let me create a data frame for updating. So that's why I'm here passing underscore RT underscore RO, right? So this right now it is unprocessed. Let me change this. Okay. So I change this to processed and change the timestamp also. So now it become processed and timestamp also changed. Now I will take this df upsert and write this. So what you have to give, same thing. Operation you have to give upsert, and let me rename the cell. So it's completed. Now let's see. Okay. I'm going to do, I am like open these two S3 folders. So in order to show you what happens actually. So see, one is like MOR. So let me open here my the COW table, and here I'm opening the current state is like I have updated both the records, right? Both the records in the table I have updated. So what happened here, I told you like it created two versions. So this is what, yeah. So here in case of COW, it's like that it's created a new versions of the file, okay, based upon the upserts. But in case of MOR table, memory on read, so see what it is doing. It is creating a log, okay, with the same ID. You can see 382140. So what will do, whatever upserts you are going to do, it is not going to create a new version of Parquet file. It will maintain a log. There it keep appending the record unless until compaction happen. So what do you mean by compaction? So what it will do, it will merge these two, right? Let's say I am at the next, after 5 minutes I am doing a compaction. So what it will do, it will merge these two log file and the record from this, and it will create a new base file, and from there uh, it will be like that base file, there will be no log file. And after that again you're doing some upsert, so it will again create a log file and maintain every changed records in the log file before the next compaction happen. So why this merge on read is write heavy efficient? Because you're not creating a new version, not creating a copy. You just keep appending a new record coming, you're just appending a log, and it is a avro file. So row based file format, it allow you to it will very efficient in heavy writes, because it just append the record at the end of the file, not like Parquet, like column based format. So that's why it is very fast. Okay, so this is the underlying difference how the data it's saved. Otherwise, if you're viewing, both will be same. So it will come with two type of view, that memory or MOR table. So what it will do, only you can have like read optimized view. It will give you the latest record from the base file. So this is base file. And if you want a real-time view, you want the latest record, So what it will do, it will merge on read, while reading it will merge with these two and it will show you, right? So let's see those things also. So now let's say I'm doing a real-time view. I want the real-time view where my real-time view, what it will give me the records I have changed. So that's the real-time view. Okay, so that's why we are going to table underscore RT, because it is real time. And if we go like read optimize, so we have to go underscore arrow. So here I shown you, right? We have created, actually Hudi creates two table to maintain merge on read table. So underscore arrow underscore RT. Underscore arrow is read optimize, underscore RT is real time. So if we want real time data, we need to query this table. If we want read optimized view, we need to query this table. And underlying architecture, what I defined you already, this is happening behind the scene. So let me run this thing again. So this is like a real-time view. Okay, we have not done this view. Okay, I'm running this cell. So this will give you the latest record. So it gives you, right, processed one means the changed record. But if you want the read optimized view, means the parquet only, means it will take the data from the base file only, right? It will not give you like the latest records. And but if compaction happen and let's say a new parquet file created after merging the log file and parquet file, then if you fire this read optimized view, it will give it will give you the latest record like this. But right now it will not give you, because still now the compaction didn't happen. All this funda I have already very much explained in the very first video. So go and watch that video. See, still from the read optimized view, I am seeing the old record, because still the compaction doesn't happen. Whatever changes we have in the log file, so and read optimized take the view from the base file, the parquet file. That's why it is showing you the old record. So that's it. This just quickly, we already saw these tables. So this is what I just wanted to show you guys this in this video, where we have seen the upsert in the COW table, and also we have created merge on read table, and we also saw like what is the underlying architecture, how the data actually saves when you're doing multiple upserts, and how both tables are different, and how merge on read table provides two type of view, like merge on read, and uh, um, two types of view, like real time view and read optimized view, right? So that's the thing. That's all for this video. Thanks for watching. Have a good day.